Hello, this is Akshay with another video here. And in today's video, we are going to take on a very important question as far as board examinations are concerned. And the question is that why is tungsten used almost exclusively for filament of electric lamps? So we need to discuss about the major properties of tungsten for which it has been chosen for the job here. So let us go through the answer here. I have just put up four major properties which are just making it a best choice as far as the filament of electric bulb is concerned. So first is the high resistivity. As you have learnt in one of my videos, that is, yes, the heating effect of electric current plays a major role in the working of electric bulb having tungsten filament in, and in that very video it has been explained that is yes, tungsten has got high resistivity, so is the high resistance, and as a result of this, according to the heating effect of electric current, heat generated in a conductor is directly proportional to its resistance. Higher the resistance, higher the heat production is gonna be, and it's so much high that it begins to emit light. That's what the point goes in its favor, is high resistivity. It needs to have high resistivity for the heating effect of electric current to show its you can say sign there, to show its vibrancy there, for the heating effect of electric current to take birth in a given conductor. The conductor needs to have high resistivity. So that's what one qualification it has got, that tungsten has got high resistivity, and it is 5.2 into 10 raised to power minus 8 ohm. So resistivity is quite high, 5.2 into 10 raised to power minus 8 ohm. High resistivity, it has got higher the resistivity, higher the resistance. So resistance, it is also going to be high. Resistance is high, then according to heating effect of electric current, heat produced in a conductor is directly proportional to the resistance. Higher the resistance, higher the heat production, and that gives you an idea that higher amount of heat is produced in that very tungsten filament. That's one thing, high resistivity, making it the best choice here. Number two, if it is not enough, another added advantage it has got, that its melting point is very high. Melting point of tungsten is 3380 degrees centigrade. Why not? It needs to have high melting point because it has to withstand the tremendous amount of heat which is gonna be produced in it. If it is having a low melting point, then I think it is not gonna survive that much amount of heat which is gonna be generated when current is begin to flow through it. So technically speaking, in order to show the heating effect of electric current, it needs to have a tendency to bear that much heat, and that's the another, you can say, added advantage it has got, that its melting point is very high. It is more than 3000 degrees centigrade, 3380 degrees centigrade. That's its melting point. One more thing, when the current begins to flow through this very thin tungsten filament, remember, thin tungsten filament, and you know this word has got its own meaning. Thinner the wire, higher the resistance, because resistance is inversely proportional to the area of cross section. We have learnt before. Thinner the wire means lower the area of cross section. Lower the area of cross section, higher the resistance of that very wire. It's low and higher the resistance, and that's why the word has got its own importance. That thin tungsten means the thinness of the tungsten will add to its already high resistance, thereby creating pronounced heat in that very, you can say, that is tungsten filament. So that's the thin tungsten filament we have chosen over here. We are very much here that its melting point is 3380 degrees centigrade. What does it mean? It means that when current begins to flow through this thin coiled structure of tungsten filament, then due to its high resistance, tremendous amount of heat is generated. Too much heat is generated. It is of such a greater level that its temperature of this very filament reaches near to 2500 degrees centigrade. It's too much high temperature. It becomes white hot at that very temperature. And remember, this is where its melting point comes into play, because it has become so hot that it has got a temperature of 2500 degrees centigrade. But thanks to its high melting point, it does not melt away. It does not breaks up. It does withstand, it bears the tremendous amount of heat which has generated during the course of heating effect of electric current, and that's why it can survive there even at higher production of heat energy thanks to its high melting point. Another specialty about the tungsten filament, and that's why it is a befitting proposition as far as the filament of electric bulb is concerned. That's the number 2, high melting point, and it withstands the tremendous amount of heat when it becomes white hot and begins to emit light there. Now the third point, high flexibility. Its flexibility. Tungsten has got high flexibility. What's the importance of having high flexibility? The importance is that you can create a desired design. You can create a desired pattern. You can give a coiled structure to the filament, and that's the coiled structure. No one wonders why the coil structure is needed. By making a coil, you enhance the surface area, you increase the surface area, and that's required, because when the heat is generated, it's the one thing. The second thing is that the heat so generated must be radiated out in the form of light. The heat so generated must spread out, and in order to spread out that very heat, its surface area must be higher, so that more the surface area, more it is being exposed, more its surface area, more the heat will be radiated out, and that's what we want. It's radiation out, or you can say that is the heat must come out or spread out. For that to happen, its surface area of the surface must be greater, and in order to increase its surface area so that it can radiate out maximum heat or maximum energy, what we are going to do, we are going to create a coiled structure. And it is only possible to have a coiled structure because it has got high flexibility. So that's another speciality about this very tungsten, that it has got high flexibility so that it can be put into a coiled structure, thereby increasing its surface area so that it can radiate out maximum amount of heat which has been generated during the course of heating effect of electric current. Next and final one, low rate of evaporation. Yes, there is always a danger for a substance which is right on at this very temperature, which is heated up to a temperature of 2500 degrees centigrade. There is a lurking danger of its evaporation at this very high temperature. It may get into vapor state and just disappears in the thin air, but that doesn't happen. Why? Because its rate of evaporation is very low. It does not evaporate so quickly, and that's why it can withstand this higher temperature without undergoing the process of evaporation. One more thing you need to learn here, that yes, this bulb, which is having a glass enclosure, is filled with argon or nitrogen, chemically unreactive gas. It is not filled with oxygen. Why? I think you understand better that why oxygen is not being taken in this very electric bulb, because oxygen is a supporter of combustion, as and when this very tungsten filament acquire the temperature of 2500 degrees centigrade, and if there is oxygen available inside this very bulb, this will undergo the process of combustion. It will burn away. it will just be in flames there. It will destroy itself over there, because the process of combustion will take place thanks to the availability of spotter of combustion called oxygen. So in order to prevent that kind of eventuality, we are going to fill this very electric bulb with chemically unreactive gas like argon or nitrogen. Now these gases are going to prolong the life of this very filament, because being unreactive in nature, being inert in nature, these gases or argon or nitrogen do not react with filament, and that's where its life is not in danger, it's safe over there. One more thing we need to keep in mind: when the electrons begin to flow through it, then what happen? That is, yes, it is a thin wire or thin tungsten filament. So too much electrons are just going through a thin passage, a narrow passage, a narrow road, and that is where the too much collisions take place. Too much collision take place means the filament, this very tungsten filament, begin to vibrate minutely there, and as a result of this, its atom begin to split out of filament. Atoms begin to split out of filament and begin to just deposit over the inner surface of this very glass cover, because the electrons are moving through this very filament and just giving a vibration to this very filament. A minute vibrations are going on. As a result of this, atoms of filament begin to split out, begin to come out and start to deposit over here. In order to prevent that kind of a eventuality as well, it is filled with argon or nitrogen. And what argon or nitrogen gonna do? These atoms which are coming out of this very tungsten filament strikes the argon or nitrogen present over here, and argon and nitrogen just you can say nudge them back onto the tungsten filament. You may say that is, yes, these atoms of tungsten which are coming out slowly and steadily are going to strike the argon or nitrogen molecules of these gases and bounce back into the tungsten filament, thereby making its life a long one, and that's how its life can be prolonged for a longer period of time. So these are the four vital points which are responsible, or which are, you can say, the main reasons that why tungsten is exclusively used in the making of filament of electric lamps. Let me recap once again. High resistivity creates more heat over there. High melting point, that's why it can survive the tremendous amount of heat being generated over there. And it is taken thin because so that its resistance, already enhanced resistance, can be increased further, so that the heating effect of electric current is gonna be pronounced one. And the third one, high flexibility, so that a coiled structure can be created in order to increase its surface area, so that it can radiate out maximum heat energy. And the last and final one, rate of evaporation is very low, and since at this very temperature there is always a danger of its evaporating, but that's not happening because its rate of evaporation is very low. So all in all, these are the vital points which are making tungsten a best choice, and that's why it is used almost exclusively for filament of electric lamps. That's it here.